Alrighty, 5-1. Congruent figures. Two objects are congruent if they have the same shape and size. So here's the definition of congruent polygons. Two polygons, including triangles, are congruent if their vertices can be matched up, so all corresponding parts, which means sides and angles, are congruent. When describing congruent polygons, vertices are listed in order of correspondence. So let's go ahead and determine the corresponding angles, the corresponding sides, and then write a congruent statement if the corresponding angles are congruent and the corresponding sides are congruent. To figure out which congruent parts of the triangles are congruent, they are marked alike. So, for instance, we have two triangles right here, triangle A, B, C, and also triangle H, J, K. So to look and see if these two triangles are congruent, I'm going to match the corresponding parts. And remember, the corresponding parts deals with angles and sides. So I can just take a look at the number of arcs. Or the number of tick marks. So let's go ahead and determine which part is congruent. I can see we're going to start off with the corresponding angles. We can see that there's one arc here for this triangle, and then there's one arc here for that triangle. This is associated with B, and this is associated with J. Since they both have one arc there, I can say that angle B is congruent to angle J. Okay? So I'm going to go ahead and highlight that so you can see. And then the next thing is I see two arcs here, two arcs there. So that means that angle A is congruent to angle H. Then we can see that there are three arcs here and three arcs there, so that means that angle C is congruent to angle K. So those are what we call corresponding angles. To find the corresponding sides, just like the corresponding angles, we look at not the arcs, but the tick marks themselves. So, since I can see that there's one tick mark here and one tick mark here, well, this tick mark is part or associated with AB, or segment AB. And this tick mark here is associated with segment HJ, okay? So I'm just going to go ahead and write that down. We say that segment AB is congruent to segment HJ. And then I see two tick marks here, that's KJ. Two tick marks there, that's BC, or segment KJ in segment BC. So segment BC is congruent to segment JK. The next one, three tick marks here associated with AC, three tick marks there associated with KH. So we can say that segment AC is congruent to segment HK. Okay, and in order doesn't really matter. You can say CA or KH. But what does matter in this case is how you write the congruence statement, okay? So if we have the corresponding angles congruent, if all the corresponding angles are congruent and all the corresponding sides are congruent, right, then we can write a congruence statement. And the order does matter, okay? So how you can write this in this case, we're going to go ahead and name the triangle. Well, at first, I called this triangle ABC, right? So this is how I'm going to write. I'm going to draw a triangle, the symbol triangle, ABC, which is congruent to triangle, and this is where the order does matter. So here's A, right? And it's part of this triangle. Whatever or how many arcs A has, the letter that has the same arc for the other triangle, in which case this is the one I'm circling, right? Then that needs to go here. Since A has 2 arcs, you have to write the letter that also has 2 arcs, right? That's first position there. You're going to write H for the first letter of that triangle. And then we take a look at B, and since B has 1 arc, you need to write the letter that has 1 arc for this other triangle, in which case it's J. And then the same thing for C. So C has 3 arcs, K has 3 arcs, so that means K has to be the third letter of your triangle. So when you're writing a congruency statement, the order does matter. And it's important that you pay attention. Okay. Alrighty. Let's go ahead and show that the polygons are congruent by identifying all the congruent corresponding parts. Then write a congruence statement. So remember, the corresponding angles must be congruent, and the corresponding sides must be congruent as well. And these are the 2 conditions that you need to write a congruency statement. So I'm going to write my corresponding angles first. And we just basically look at the number of arcs, okay? So I have this particular polygon right here. We don't have a specific name, but it's a polygon. And by the way, a polygon, by definition, I'm just pulling up in Google because Google has a great way. It's to the point. A polygon is a plane figure with at least 3 straight sides and angles. So we have 1, 2, 3, 4. 1, 2, 3, 4. So it has at least 3 straight sides and also angles. So let's go ahead and figure out the corresponding angles. Again, we're just going to look at the number of arcs, right? I'm comparing this polygon to this polygon. So I can see that angle P, since it has 1 arc here, it's congruent to angle G. And then angle Q has 2 arcs here, so I compare that to angle F. So angle Q is congruent to angle F. Okay, and then the next thing is, since this has 3 arcs, that is congruent. So R is congruent to angle E. And then this has 4 arcs, so I'm comparing that to angle D. So angle S is congruent to angle D. Okay, so these are my corresponding angles. So now I need to go ahead and find my corresponding sides. Okay, and the corresponding sides must be congruent. And again, these things here are the sides, but they are the edges. Okay, so I see that this side has 1 arc and this side has 1 arc. So I can say segment PQ is congruent to segment GF. And then the next thing is segment PS. Segment PS is congruent to segment DG. And then segment SR, since it has 3 arcs, it's congruent to segment DE. So segment SR is congruent to segment DE. And don't forget to write the segment bar. And then what else do I have here? Am I missing something? 1, 2, 3, 4. 1, 2, 3. This is weird. This looks like it has 3 arcs here, doesn't it? So segment QR, let's go ahead and put 1 more arc there and another arc there. Segment QR is congruent to segment EF. Alright, apologies if it looks like it has 3 arcs there instead of 4. Alright, so alrighty, I just want to go ahead and make a quick edit because I told y'all to add a tick mark here and a tick mark here. We're not going to go ahead and do that. In fact, we're going to basically go along with what we have here because the notes were taken from the book and it seems like it was intentional that we have the 3 tick marks here and the 3 tick marks here on the same figure, and that applies to this figure as well. So let's go ahead and just start over real fast. I'm gonna go a little quick though. We said that segment PQ is congruent to segment GF, and that's because they have 1 tick mark. And I look at segment SP, which is congruent to segment DG. So those are really, really easy to, determine because of the number of tick marks. And then I'm going to get into this territory where, again, we have 3 tick marks here. And if I were to choose, segment QR, does it correspond with segment EF or segment DE? Well, remember, we're talking about correspondence, right? Or corresponding. We're talking about location. So if we were to take a look at segment QR, well, those 3 tick marks, they're between the angles with 2 arcs and 3 arcs. So then that means I need to look at this figure with the 3 tick marks that's between the 2 arcs and the 3 arcs. So in this case, it's this. Segment FE has the 3 tick marks where it's between the 3 arcs and the 2 arcs, just like QR has. So those correspond. So segment QR is congruent to segment EF. And then in this case, segment SR is congruent to segment DE. Now what I want to go ahead and do is I'm going to go ahead and write my congruent statement. And to do that, you're going to have to pick one polygon. In this case, I'm going to pick the one on the left. And I'm going to call it P, Q, R, S, close it. So the symbol for polygon, there isn't one, so I'm just going to have to write polygon instead of drawing a symbol because there isn't one. So I called it polygon P, Q, R, S, P, Q, R, S, close it, is congruent to, again, order matters. So here's angle P. The letter that must be here has to have that one arc. So in this case, it's G. Okay, so I need to write polygon G, then Q, right, goes with F, and then R, it goes with E, and then S, it goes with E. Wait. D, sorry. So there's 4 arcs here and 4 arcs here. I don't write E because I already did. I meant to put D. So this is what we call polygon PQRS, which is congruent to polygon GFED. Okay, so that's my congruency statement. All right, if 2 triangles are congruent, then all the corresponding parts are congruent. And we have this, which is super important that you know, CPCTC, which means corresponding parts of congruent triangles are congruent. So, again, if 2 triangles are congruent, then all corresponding parts are congruent. So, when you have a congruency statement, which we already have here, this is where CPCTC applies, right? Again, when you're writing a congruency statement, the order matters, right? So with CPCTC, if I say that what is congruent to angle A, right? If I were to compare this triangle to this triangle, whatever is congruent to angle A, well, since A is in the first position, and I look at the other figure, D has to be congruent to angle A, and that's by CPCTC. Angle B is in the second position, whatever is, the other figure is congruent to angle B, then that has to be congruent, in which case it's angle F. Again, that's by CPCTC. And then C is congruent to angle E, okay? That's dealing with angles. If I were to talk about sides, then I would say, like, segment AB, since this is the first 2 letters of this triangle, then what's congruent to segment AB? Well, it would be DF, because in this triangle, DF is the first 2 letters. Okay, so that's how CPCTC works, if that makes sense. Okay, so let me go ahead and write stuff down. Again, this is by using CPCTC. So I have 2 triangles right here. Okay, so I have these 2 triangles right here. And we say that angle A is congruent. So angle A is congruent to angle D because it's the first letter, or both of them are the first letter of their own, statement, and that's by CPCTC. And then angle B is congruent to angle F, and that's by CPCTC. And then I'm going to use a different color. angle C is congruent to angle E by CPCTC. Okay? And that's dealing with the corresponding angles, based on the positioning or where they're located, right? Again, order does matter. And then what I'm going to go ahead and do is take a look at corresponding sides. So we know that we can say for sure that, let me see, hold on, let me think. So there's A, B, C. Okay. Figured it out. So the first two letters, segment AB, what's congruent to segment AB? Well, it's segment DF, right? So I'm going to use blue this whole time. So segment AB is congruent to segment DF. And then the last two letters, what's congruent to the last two letters over here? Well, segment FE, right? So segment BC is congruent to segment FE. And then what happens if I say the first and the last letter? What's congruent to the first and the last letter? It would be segment DE. So segment AC is congruent to segment DE. Okay, and this is all by CPCTC. All right, so now what I want to go ahead and do is I want to find the values of X and Y. Okay, so here is my Y, and here is my Y and an X. So, what do I have to do? Well, first of all, I know for sure that this angle is pointing here, or this expression is pointing at this angle. So it's angle F, right? So if I go back over here, we know that angle F is congruent to angle B. And those two things are congruent, right? So B has to equal F. So then I can go ahead and do my algebra. So since B is 99 and F is 8y minus 5, well, if I use the addition property of equality, I get 104 equals 8y. Then I use my division property of equality, I get y equals 13. Okay, so this is going to be great since I found what y is. Then I'm going to go ahead and take a look at FE. Okay, since 2y plus, that's how long the measure of FE is. It's 2y plus x units. So I'm taking a look at this. FE is right here, and it's congruent to BC. So FE is congruent to BC. Again, that's by CPCTC. So I write 2y plus x is equal to, again, FE is equal to BC, right? I should write that down. So FE is equal to BC, and then I'm going to substitute 2y plus x is equal to 38.4. Okay, and what am I going to solve for? Well, I already know what y is equal to, so I need to look for what x is equal to. But notice that I have two different variables here, and since y is equal to 13, I'm going to replace that y with 13. So I have 2 times 13 plus x is equal to 38.4. And that's actually going to be 26, right? 2 times 13 is 26. And then nothing's going to happen to that plus sign in the x. And nothing's going to happen to that 38.4 just yet, because now I'm going to use the subtraction property of equality, because I'm going to subtract both sides by 26, and I get x is equal to 12.4. And this is my answer. Okay. Let's go ahead and look at this diagram. Triangle RSV is congruent to triangle TVS, okay? So this is a given. We can assume that these two triangles are congruent. If I go over here, this is also a given because I can assume that these two triangles are congruent. And since you see that these two triangles are congruent, right, you can use the CP/CTC rule. And that also applies to the polygons that we've talked about before, okay? If the polygons are congruent right off the bat, then you can use CP/CTC. Okay, so what am I looking for? Well, first of all, we know that these two triangles are congruent, and now my goal here is to find the values of x and y. Okay, so let's go ahead and do that. I see that x is associated to t. So I'm going to go ahead and take a look at my congruency statement. Since t has the variable that I want, and t is the first letter, I also look at the other triangle and look at the first letter, okay? Because those two things are congruent by CP/CTC, right? And then t is equal to it's actually measure angle t is equal to the measure angle r, and that's me using definition of congruence. Then I'm going to use the substitution rule, because measure angle t is x, and then here is measure angle r, right? Here's measure angle r. Well, we don't have anything for measure angle r. There's nothing right there. But if we take a look at the triangle very, very closely, well, we see that this angle here is 78. This here is 90 degrees. So how long is this angle? Well, we know that a triangle, they add up to 180. 78 is part of my 180. 90 is part of my 180. So what's left? It's 12 degrees. So then measure angle R is 12, and that's all I need to do. I just found X. Let's go ahead and figure out what Y is. So there's 2y minus 1, and it's part of RS. I'm going to take a look. Here's R, and here's S. So these are the first two letters, right? So by CP/CTC, if I'm comparing this triangle to this triangle, since RS is the first two letters, then TV has to be congruent to RS because it's the first two letters for this triangle. So segment RS is congruent to segment TV by CP/CTC. And then using the language of algebra, RS is 2y minus 1, and TV is 24. So 2y is equal to 25, and then y is equal to 24 over 2, which simplifies to 12.5. Let's go ahead and talk about the third angles theorem. If two angles of one triangle are congruent to two angles of a second angle, let me reread this. If two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangle are congruent. So what that means here is that, okay, well, this angle here and this angle here are congruent. and then this angle here and this angle here are congruent, well, obviously or logically, this angle and this angle here has to be congruent, right? So if I were to say this is, I don't know, this is 40 degrees, and this has to be 40 degrees, and then this is 60 degrees, and this is 60 degrees. Well, cool. Well, how long is this angle, and how long is this angle? Well, 100, sorry, not 100, since when you add up all the angles, it should equal to 180, right? So 180 minus 60 minus 40, that is 80. So this angle here is 80 degrees. Therefore, this angle here has to be 80 degrees. This is what we call the third angles theorem, okay? So if angle C is congruent to angle K, and angle B is congruent to angle J, then that implies that angle A is congruent to angle L. Has to be. All right, so find the value of X. So I can see that there are two arcs here. There are two arcs there. This has to be 55 degrees. And then I see that this is one arc here, and this is one arc here. This has to be 65 degrees, okay? So angle M, well, I do 180 minus 55 minus 65, that's 60 degrees, okay? So this angle here is 60 degrees. So that means that this angle here has to equal 60 degrees as well, okay? But I'm solving for X, right? So find the value of X. So since 2x plus 30 is 60, since 2x plus 30 is 60 degrees, then, well, we know for sure that angle M is congruent to angle T, no doubt about that. So the measure angle M has to equal to the measure angle T, since 2x plus 30 is, remember, is means equal, it has to equal 60 degrees, right? So then I'm going to do my algebra. So x is equal to 15.